Okay, now I show you the next example, that is example 6b. Okay, if fx is sine cube x by using the repeated differentiation, show that f double prime x plus this 9fx is 6 sine x, and then f7, that means we are going to differentiate 7 times until d7y dx7, then hence obtain the series expansion. Of course, we are going to use the Maclaurin series, Maclaurin theorem, and we are going to get until x to the power of 7. Okay, so I just show you now how to get this. Okay, look at this. Okay, now you are given fx equal to sine cube x. Of course, this one I call it as 1 because Maclaurin, afterward we are going to substitute x equal to 0 inside here. Okay, so I put x equal to 0, f0 with sine 0 is 0. Okay, then I have to differentiate 7 times. Okay, now this is the first derivative, f prime x. So whenever the differentiate, I bring down the 3, then this one become 2. So 3 sine square x, and then I differentiate the sine x, I will get the cos x. Okay, so here I just see whether I can do anything or not. I can bring this one in or not, cannot, because this is sine cube, this is sine square, cannot. So I just write like this. Okay, and then this one I can change to 1 minus cos square. Cos square x, yes. Okay, so I change it like this. Okay, you see this one and this one. If you compare these two, this will be easier to integrate. Because why? As what I said, this house only one people staying. This one also one person staying. But this one, if you use this one to differentiate, this house got 2 person. So it's more difficult if you have like this. So if possible, you try to change to 1 person like this. So it will be easier. Okay, this one I put it as 2. Afterward, I'm going to put x equal to 0. I will get cos 0 is 1. This one also 1. So it's 3 minus 3 also 0. Okay, now, so I differentiate. Differentiate this one, you see, so easier to differentiate like this. So you differentiate cos, you get negative sign. And then here you differentiate the cos cube, you bring down the 3, then cos square x. And then here you have differentiate the cos, you will get negative sign, is it? Then you simplify. Okay, when you simplify, you will get this one, and then here you get 9 cos square sine x. Okay, then after that we use again the identity. Now when I substitute the cos square is 1 minus sine square, then I will get, after that I will get this. I will get f double prime. Okay, so you see I can see the sine cube x is already here. Why? Because I can substitute as fx here. This sine cube x I can substitute. Okay, I can substitute here. So afterward will be easier to differentiate. Okay, so I just substitute inside. That's why I get f double prime 6 sine x plus 9, minus 9 fx. This is fx. Okay, from number 1 just now, sine cube x. Okay, so you will see that this one, if I simplify, I can put it like this. Same, either you like put like this or put like this, because you are asked to show this, so you have to follow. Okay, you have to show. Okay, now you see this is easier to differentiate. This one you can differentiate many times, no problem, isn't it? You just, after that is 3 triple prime, and then 3 4 5 6 7 8 until 10. Like this one also same, and this is also easy. This one become cos, then after you differentiate cos, you get negative sign, so you will get this. Okay, number 3. So this is number 3, f double prime. Okay, then you see very easy now. f2 you differentiate become f3. Okay, third derivative. This one first become this one fx, you differentiate become first derivative. Sine become cos. Okay, so this is number 4. So now you can see you can keep on differentiate many times. Okay, so this is third become fourth, second differentiate, first differentiate become second, and then this one become negative. Cos differentiate negative sign. Then differentiate again. This one fourth derivative become fifth derivative. Second become third. Here sine become cos. Okay, so this is number 6. And then you differentiate again because you want to get until 7 derivative. So differentiate again. Here you get 6. Third become 4. Cos become negative sign. Okay, that's why become positive over there. Okay, then number 8. This is the last one because we are going to stop here. So this one 6 derivative becomes 7, 4 become 5th, sine become cos. So that's all finished. So we differentiate until here because we are asked to show this. Okay, so after that we are going to substitute x equal to 0. As what I said just now, you substitute x equal to 0 here, x equal to 0 here, x equal to 0 here, all this. So what will you get? You see, when I substitute x equal to 0 into 1, I get f0 is sine 0 is 0. That's why I get sine 0 is 0. Okay, as you see here. Then I'm going to substitute into x equal to 0 into number 2 here. So when I substitute x equal to 0, I get 3 cos 0 is 1 minus 3 cos 0 is 1. So I get 0 minus 0. Again, I will get 0. That's why I get 0 again. Okay. Then after that, I'm going to substitute x equal to 0 into number 3 here. Number 3. So, okay, number 3, I get f double prime 0. This one just now, f0 is 0 from number 1 just now. Here. Then sine 0 also 0. That's why I get again 0. Okay, then I just continue. Okay, now I continue to substitute. Okay, like this. Okay, now I just substitute into number 4. You see, number 4. Okay, just show you here. I substitute x equal to 0. I will get, okay, f triple prime 0 and then f prime 0. Okay, equal to 6 cos 0. 6 cos 0 is 1. So just now this one f dy dx, first derivative is 0. That's why triple prime is 6. And then after that, I substitute into 5 here. I substitute. Okay, then this is what I get. F double prime just now also still 0. So I get this. Okay, I get 0. Okay, then I substitute into number 6. Okay, so I get this. So I simplify, I put 0. But this one just now, f triple prime 0 is 6, it's not 0. So I will get, bring this over, I get negative 60. Then I substitute again into number 7. Then I will get this. Okay, you slowly check back, you will see, you will get this. Number 6, you still get 0. So finally, we come to this. Okay, f7, 0. So you have this 6, and then just now this one f5 is here, negative 60. So I substitute, I get 546. And then okay, then according to Maclaurin theorem, we are going to find x cube x. So it's fx, f prime 0, f double prime 0, f triple prime, and then so on. So you just substitute all those values you get just now. So 0, 0, 0. Then this is f triple prime is 6. And f5 is negative 60, and then this one f7 is 546. So you just substitute. Okay, after you substitute, you will get this. All the 0 you can just ignore. You only take those with the value non-zero one. Okay, these are all the non-zero terms for x sine cube x, and then you simplify. Okay, you will get this. Okay, that's all. Okay, now the last part. What are we going to do? The last part you are asked to integrate. Okay, evaluate, find the value of the integral. Okay, the limit is from 0 to 0.2, and then it's sine cube x over x cube dx. Of course, this one, if you want to integrate, is impossible. That's why we have to use the Maclaurin series to do it. Okay, you cannot integrate it. And then correct to 4 decimal places. Okay, so we are going to find the 4 decimal places. Okay, so what we have to do here, you look at here. Okay, we are going to integrate this. So since we are going to integrate this, we just, okay, here we just put in our x cube just now, our x series expansion here. This is what you get just now, and then divide by x3. So when you divide by x3, then the x3 you can cancel. Then here you have x squared. This one you have x4. X4 actually is x4. Okay, this is x4 because you divide by x. This is x4. Okay. Okay. Then after that you are asked to integrate. So you have to integrate. So you integrate from 0 to, that means when you integrate the left hand side, this side, from 0 to 0.2, here also you have to integrate. And then this is x4, okay? This is x4. This is x4. Okay? Now, so here, and then you integrate, okay? So you can integrate, this is x cubed over 3 half, then 13 over 12. This is actually x5 over 5, okay? x5 over 5. Then you find the value one by one. That means this is 600. This should be 600. This should be 600. This one should be 600, and this is power 5. Okay, this is power 5. So when you use the calculator, you find all this. This is the answer. Okay, and this one, even though just now I make the mistake, but it won't affect this answer. Okay, because this is too small for 4 decimal places. If you press the calculator, I think this one should be, the 0 must be more than 4. Should be something 1, 2, 3, 4, 0 something. You can use calculator, you press and see, so that this one doesn't affect the answer to 4 decimal places, because here is too small. Okay, it's too small. Okay, that's all. This is the answer. Okay.